Okay, so the first thing we're going to obviously do is a cross tabulation. That's because it's looking at nominal and ordinal level measures. And obviously those are our lower level orders, and so we want to start there. All right. So I'll show you in your lab how to actually get these tables, and so use that as your measure for use that as your tutorial for how to actually produce these tables. What I want to show you here is how to use the tables to begin the interpretation process. So when you get a crosstab table, you'll get what is this case processing summary, and it basically says how many people were included in the analysis, and then how many people came out of the analysis, and it should equal your total number of cases in the sample. All right. This first table is used. What you're basically looking at is the relationship between gang association, the computed gang association, and sex or gender. So your variables are between gang association and sex. The um, the next table that you get is what we refer to as a contingency table, and it's called a contingency table because one set of variables will be contingent upon the responses in the other set. Okay, so the responses for gang association are contingent upon whether or not you're a female or male, related to no association, thought about it but did not join, and then thought about it and joined. All right, and in this contingency table also note that the protocol will always be that your dependent variable false will come here. So gang association is considered a dependent variable, um, and that then the independent variable in this case would be sex or gender. All right. Um, Now that is going to be my protocol. It might not always fall that you see it in that manner. But for the most part, most people do that. But just in case you're not sure how to read a contingency table, look where the 100% follow or fall. If they fall in the column, which these do, then what's in that column is considered your independent variable. All right, so in this case, because sex is in the column, our 100% fall at the bottom of that column, then sex is our independent variable. If your 100% fell all over here, then your independent variable would be on this side where gang association is. But in this case, because our 100% fell in our column, our gang association then would be referred to our row values. All right, and these are considered the row values here. All right, so these are the rows. Switch this guy out, make it a row. All right. So the yellows are our columns and the greens are our rows. And because wherever your dependent variable fall, and in this case it's in our rows, then you read across the row, you interpret across that row or interpret across the dependent variable. Alright? Alrighty. The next thing that you note is our measure of association. Alright? I actually asked for a lot of measures of association. I asked for the lambda, I asked for the gamma, and the Pearson's R. And always when you ask for all of these, the Spearman correlation will also give you a value. Alright? And the reason why I wanted to show you that is this. Our independent variable is a nominal level measure. Our dependent variable is an ordinal level measure. And because the higher order variable, regardless if it's the the independent variable or the dependent variable, whichever is the higher order variable, is the measure of association you will interpret. And because we know, first of all, that Pearson's R is a measure of association for interval ratio level measures, we know we won't be interpreting that. So our choices are between lambda and gamma. Between lambda and gamma. And again, because our gang association is a nominal level measure, our sex is a nominal level measure, the appropriate value to interpret then would be what? No association, thought about it but did not join, thought about it and joined, and sex is a nominal level measure, then we want to interpret the lambda rather. Okay, so this is our lambda value. This is our level, this is our significance. This is that p-value that we talked about earlier. So this is our p-value. All right. All right, so given that, and I just wanted to again point out where these things are, and we'll get into interpretation later. So again, we have gang association and county, and 0 is out of county, 1 is in county. And again, this would be considered a, oh, let me go back. The last thing is our chi-square. So our chi-square value is 25.7 here, and this is the p-value associated with, and the degrees of freedom associated with that chi-square. So remember I told you about degrees of freedom and our p-value. So if you have, in this case we have 3 rows and 2 columns, and given the formula that I gave you before, where r minus 1 times c minus 1 would give us a degrees of freedom of 2. Alright, and that's the case here. Alright, it appears that SPSS is treating the gang association as a ordinal level measure and not a nominal level measure, because I'm noticing that the gamma values are higher. Alright, I'm noticing that these gamma values are higher. Again, this is their p-value, so that's not what I'm focusing on. I'm focusing on this 0.343 versus the 0.086, and the reason why I'm saying that it must be treating as a nominal level, ordinal level measure is when I jump down here to looking at gang association versus county, or by county, the lambda value has no value. But look over here, the gamma value actually does give us a value of a 0.169. So we need to go ahead and treat that as a ordinal level measure, because it appears that SPSS believes it is an ordinal level measure. Alright? If we were calculating this ourselves, we would treat it most certainly as a nominal, but we need to go with what SPSS has given us in this case. Okay?